These are the solutions for the study guide for Chapter 7, Section 4 extension in Chapter 7, Section 5. So let's take a look at our first problem that we're going to see on the test this week. And what we'll end up having to do is simplify a fraction, or actually change this, convert this repeating decimal into a simplified fraction. And so we'll have to explain and show each step. So what I'm looking at is, first of all, I'm going to set x equal to 0.5 repeated. So you always set your variable equal to the part that repeats, and then I'm going to multiply by 10. I'm going to multiply by whatever, a factor of 10 of how many ever numbers repeat. So if one number repeats, then I'm going to multiply by 10. Two numbers repeat, I'm going to end up multiplying by 100, and so on. And so let's take a look at the first part here. If I multiply 10 by x, I get 10x. Then if I multiply 10 by 0.5, I end up with 5.5 repeated. And then what I'm going to end up doing is I'm going to subtract x from both sides. Well, 10x minus x makes 9x. Well, I can't subtract x from the right-hand side, but since x equals 0.5 repeated, I'm going to subtract that 0.5 repeated from both sides. And what will cancel out is the part that repeats, so now we can actually do some division. So I couldn't do division before because I always had this infinite number of repeating numbers. Number 5 was repeating an infinite number of times, so I couldn't set up the division problem. But now I can, since I have a terminating number. It terminates right after the 5. And so I get my answer of x equals 5/9. Let's take a look at the next one. What's different about this one is only the 6 repeats. But you do the same thing. You let x equal the part that repeats, including the number that did not repeat. And so I just use whatever is the fraction, not the whole number. If it were a whole number like a 1, I would kind of ignore that number, and in the end I'll make it a mixed number. I'll have 1 and then if this was, let's say, 1.5 repeated, I would have 1 and 5/9. In this case, again, just 0, so no need to worry about that. So I'm going to multiply by 10, and that's going to move the decimal over one space. Now what I'm going to do is I'm going to add an extra 6 there. The part that repeats is what I want to cancel out, but I'm going to end up having to subtract this 0.36, so I want to make sure I line up the parts that repeat. That's why I added this extra 6 here. And so I go ahead and do that subtraction, and then the same thing on this side. So I end up with 9x equals, and then when I do the subtraction, I get 3.3. How do I do that? Well, the 6's reduce, or cancel, and 6 minus 3 makes 3. And so now I'm ready to divide by 9, and when I do that, the decimal point moves, well, I'm going to multiply by 10 over 10 to move that decimal point over one space, so I get 33, and then down below I get 90. And so I'm just going to take out the common factor of 3, and when I do that, I end up with 11/30 is the answer. Well, let's take a look at our next problem. On this one, what we're trying to do is we're trying to see if this forms a right triangle. Does the rope form a right triangle? And so they give us all the side lengths. So what we're going to use is the converse of the Pythagorean theorem. We're going to square a squared plus b squared, set it equal to the longest side squared. So longest side is 80. And so I go ahead and substitute my numbers in there. 48 squared plus 64 squared equals 80 squared. And so when I do the work, I square 48. Now I'm going to go ahead and take the square root of each of these numbers. So when I square 48, I end up getting 2,304. I square 64, and I get 4,096. And I square 80, well, 8 times 8 is 64, so I'll add 2 zeros to the end of that, and that's what I end up getting. Now when I go ahead and add these two numbers together, hey, I end up getting that exact number. I end up getting 6,400, and on this side I have the same exact answer. And so this means, yes, the triangle is right. Yes, the triangle is right. And then our reasoning would be this. Because the side lengths satisfy the converse of the Pythagorean theorem. Alright, so let's move on to the next set of problems here. And it says this. It says find the distance between the 2 points. And so what we can do is we can use the distance formula. And so you can always sketch a coordinate plane and then plot the points and then find out the distance between those points horizontally and vertically, or we can use this distance formula. The distance formula goes this way. The square root of the two x values, x minus x1 quantity squared, plus the difference of the two y values, y minus y1 quantity squared. And so I'm going to take the two x values and I'm going to find the distance between them by taking their difference, 12 minus negative 12. And when I do that work, I add the opposite here and I get 24. And I'm going to square that number. Over here, I do the same thing. I take the difference of the two y values, 5 minus negative 2, and I square them. And so again, I add the opposite, and that gives me 7. And so 7 squared. And so I square these numbers, and that gives me 576. And then I square 49, I get, or square 7, I get 49. And when I add those two numbers together, that gives me 625. And so when I take the square root of 625, that's going to be the distance. And that distance is 25. So 25 units is my answer. The next problem asks me, how far is the cabin from the peak? Well, here's the peak, here's the cabin. We're trying to find out what this distance is. And so since we've got a coordinate plane, we can just use the coordinates on this, the units going down vertically. I can count the spaces. So you've got 1, 2, 3, 4, 5 spaces. Same thing going across this way. I can count the spaces. 1, 2, 3. And so I can go ahead and set up Pythagorean's theorem. 5 squared plus 3 squared equals x squared, the distance between the cabin and the peak. So this makes 25 and 9, and this makes x squared. And I go ahead and add these two numbers together, I get 34. And so I'm trying to find out what the square root of 34 is. And so I can go ahead and approximate this. And so we have got some perfect squares that 34 is between, 36 and 25. And I see that the square root of 25 is 5, square root of 36 is 6. So I see the number, square root of 34, is going to be really close in between these two values. And a good approximation might be about 5.8 or so. So at 5.8 units, 1 unit is a kilometer, so 5.8 kilometers. Pretty good estimation of what that is. The next problem says, your friend runs the play as shown. Did your friend make a 90-degree turn? Okay, so what we're going to do is we're going to find out what the distance between these 2 points are. And so if I look at this distance here, this is 3. And if I look at this distance between these 2 points, it's 3. And so I'm going to find out what the distance for D1 is. So D1 is going to end up being 3 squared plus 3 squared. And so I'm going to take that square root, and that's going to end up giving me the square root of 9 plus 9 makes 18. Now look at the distance for distance 2. And so all I'm trying to do is find out what these distances are. Now I'm not taking the square root. I'm going to leave it in that exact form. And so I do the same thing on the next one. So it looks like the distance vertical is 1, 2, 3, 4, 5. So 5 spaces down, and 1, 2, 3, 4, 5. 5 spaces across. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, 5 squared and 5 squared. And so when I square both those numbers, the horizontal and the vertical distance, that gives me 25 and 25 make 50. And so I have 50. Square root of 50 is that distance for distance 2. Now distance 3 is going to be my hypotenuse. So I'm going to count the horizontal distance and the vertical distance going down. And so I see that horizontal distance is 2. Vertical distance is 1, 2, 3, 4, 5, 6, 7, 8 spaces. And so when I set this up, it's going to be 2 squared plus 8 squared. And that's going to give me 4 plus 64. And that's going to give me square root of 68. Alright, so now I'm going to use the converse of the Pythagorean theorem. So it's going to be d1 squared plus d2 squared, or actually, the d2 squared and then equals d3 squared, because d3 is the hypotenuse. And so what I'll do is I'll substitute my numbers in there. And so I've got the square root of 18 plus, and that's going to be squared, plus the square root of 50 squared equals the square root of 68 squared. And so when I do this work, the squaring cancels out the radical sign. And so when we do that, what we're left with is the radicand. 18 plus 50, and equals 68. And so I see that these two numbers do equal 68. So here's the phrase that we'll end up using to explain our answer. And I'll write it in here. So what I said here is, yes, your friend did make a right triangle. And they made a right triangle because the side lengths satisfy the converse of the Pythagorean theorem. So let's take a look at the last three problems. And the first one here says that we're supposed to evaluate the expression. So just as a square root was canceled out by squaring it, a cubic root is canceled out by cubing it. And so we're just left with the radicand of negative 64. So we just add 43 to that number, and that gives us negative 21. On the next problem, we're supposed to find the measure of the exterior angles, and that's these angles here. And so what we do is we have to know that all exterior angles, no matter what kind of polygon it is, all sum to 360. So we're going to add up all of the angles, 34, x, and 90, and it's a 90 because of the right triangle, right angle symbol there, equals 360. So we go ahead and add some numbers together. So this is 2x plus 124 equals 360. So we subtract the 124 from both sides, and we're left with 236 equals 2x. So when I divide by 2, we end up with the answer x equals 118 degrees. And so we just go ahead and write in 118 degrees next to the angle that was x, and then the other two are given to me. And maybe just write down this one's 90 since it doesn't actually have that number. And the last one says that the table shows the amount of gasoline in gallons left in a tank after the number of m miles. Write a linear function that relates the amount of gasoline to the traveling distance. So that's your slope. So your slope is gasoline to traveling distance. Alright, so we're going to set up the slope formula. So the gasoline consumed, so 20 minus 19 all over, and then since I start with the 20, I got to start with the 0. 0 minus 20. So I see this number is going to be 1 over negative 20. So what that means, it might be easier to see it the other way, negative 1 over 20. That means negative 1 means gallons of gasoline. So you're losing 1 gallon of gasoline for every 20 miles is what that represents. And so we're going to go ahead and write this as a function. And the way I'll do that is I'll take the values that they want us to use. So m miles, g gallons. So I'm saying g gallons of gasoline. And actually, we've got to actually find out what the y-intercept is. So I'm going to go ahead and write in g minus, and then I'm going to take away one of these values. Let's go with 20 equals negative 1/20th times by the number of miles, m, that's what they wanted me to use here, minus 0. And so when I go ahead and distribute this, I've got g minus 20 equals negative 1/20th m, and then I'll go ahead and add the 20 to both sides. And so my equation is this. My equation is g equals negative 1/20th m plus 20. And so that was my equation. So I wrote my equation. Now it says how many gallons of gasoline are left after traveling 120 miles. So m stands for the number of miles. So let's go ahead and plug in that 120 there and add the 20 and find out how many gallons of gasoline are left. And so we're going to go ahead and do some division here. 2 into 12 goes 6 times, and the zeros cancel out. So that's negative 6 plus 20 makes 14. So 14 gallons are left after we travel that 120 miles. So those are the types of problems you're going to see on this week's test. Good luck.